We're going to begin by looking at vertical shifts. So first we're going to look at these vertical or up and down shifts. These shifts were created by adding a constant value to a known function. Using function notation, we might write, or we would say, suppose we were given y equals f of x, we would have a vertical shift when we write a new function g of x equals the old function f of x plus k. The easiest way to illustrate this is to take a look at an example, and let's look at a fairly common function, one I'm sure you're comfortable with. Let's take a look at shifts of f of x equals x squared. So first of all, if I graph f of x equals x squared, we get our standard parabola with a vertex at the origin, concave up, opens up, axis of symmetry is the y-axis. Again, you're all really quite comfortable with this. If we then graphed a function we'll call b at x, which is x squared plus 2, notice what happens is the whole graph is just picked up and moved up 2. And in fact, probably the easiest thing to say is that a general point AB is actually going to be shifted to the point A, B plus 2. So notice with this vertical shift, with this x squared plus 2 shift, the A stays the same, but the y coordinate, the B, we just add 2 to. So the only effect of a vertical shift is on the y value. It keeps all the x's the same, and it just takes the y's and either adds to them or subtracts from them. Let's take a look at a subtraction example. Whoops. Suppose my subtraction example, went a little too far here, is c of x equals x squared minus 3. So notice now when I graph this function, it's taken the whole graph and it's moved it down 3 from the regular x squared function. So notice now the point AB is shifted to the point A. Again, the x coordinate stays the same, but the y coordinate gets subtracted by 3. So notice, if y equals f at x is a function and k is a constant, then the graph of y equals f at x plus k is the graph of f at x shifted up or down k units. If k is positive, the shift is vertically upward, and if k is negative, the shift is vertically downward. Let's take a look at tables for x squared plus 2, and x squared minus 3. So if I take a look first at f at x equals x squared, I just happen to pick the values from -2 on up to 3. So I did -2, -1, 0, 1, 2, and 3. And I squared them, so that gives me 4, 1, 0, 1, 4, 9. If I did x squared plus 2, notice what I said is it doesn't affect the x's. So I'm going to keep all the same x's. And notice the y's I get are exactly the same y's I had before, just added 2 for each corresponding value. Notice, by the way, without doing the math out, we could have just taken each point A, B in the first table and changed them into A, B plus 2 to create the second table. And you are going to be asked to do that in your homework and on tests. You won't be given the function, but you'll just be told, suppose f at x is this table, and g at x is the table plus 2, is f at x plus 2, and you would need to know that you keep the x's and just alter the y's. Notice I did the same thing with x squared, f at x equals x squared minus 3. So again, I could get that table from the original table just by keeping the x's, vertical shifts keep the x's, and just subtracting 3 from each of the y's. So again, notice without doing the function evaluation, we could just take each point AB in the first table and change it into A, B minus 3 to create the second table. Notice, by the way, when we add or subtract a constant from the entire function, we refer to this once again as a vertical shift, or you sometimes will hear me refer to it as an outside shift. And we'll see what I mean by an inside shift in a couple of minutes. But an outside shift. Outside shifts affect the y's only. So anytime I have an outside shift, the x's will stay the same, the y's will change. So just remember that vertical shifts are outside shifts. they only affect the y values.